So as we start to talk about error, otherwise called remainder, we're going to start with this alternating series. So I have this alternating series. I have negative 2/3 to the n power, and we're just going to kind of explore this a little bit and look at what these partial sums look like. So at first I'm going to list out the terms of this series, and then we'll talk about the partial sums. So it goes 1 minus 2/3 plus 4/9 minus 8/27 plus 16/81 minus 32 240/3, and it continues on like that. Right, so you can see that the magnitude of each term decreases, right? The terms are alternating, and the limit of the terms is approaching 0. Right, so this is an alternating series that does converge. All right, let's look at the partial sums. S sub 1 is 1. S sub 2 is 1/3. That's 1 minus 2/3. S sub 3 is 7/9. S sub 4 is 13/27. S sub 5 is 55/81, and S sub 6 is 133 240/3. Right, so it's kind of difficult to see when we just look at these partial sums, but what I've done is graphed these partial sums. So if you take a look here, I've graphed these partial sums. So here's one. You can see the scale. My x-axis is down here. So here's 1/3. Here's 7/9. Here's 13/27. Here's 55/81. Here's 133 240/3. Alright, so this is a converging alternating series, and we can see that as we add up these terms, our partial sums bounce above and below what looks to be the actual value that this sum is going to, the infinite sum is going to converge to. Alright, so each time we subtract a term, we add a term, we subtract a term, we add a term, we subtract a term, we get closer and closer and closer, and we're either above, below, above, below, above, below the actual infinite sum. Right, so this leads us to this conclusion that the error, so if I take the 1, 2, 3, 4, if I take the fifth partial sum, let's write that as sub 5. Right, the distance between where I am and where the true infinite sum is going to be less than the distance to the next partial sum. Okay, the distance to that next partial sum, this right here, is when we subtract that sixth term. So we're at the fifth partial sum, then we subtract the next term, and we go past the actual infinite sum down to the sixth partial sum. And at the sixth partial sum, we're going to add that seventh term back on. It's going to bring us above. So we know that the true value is in between there. Right, so what that means is that our error, or our remainder, is always going to be less than the absolute magnitude of the very next term in that series.